Eureka mathematicians, and I'm so excited to tell you that we have two gentlemen scholars that are going to take over the reins for today's video for lesson 30. Beautiful. What are we working on in lesson 30 today?
Dividing decimals by decimals.
How are we just doing it traditional algorithm?
No, we're turning them into fractions and then multiplying them by the decimal ratio.
Okay. On a scale of 1 to super tricky, how tricky is this?
Kind of in the middle.
Kind of in the middle.
3.
Okay. Do you feel like we're ready for it?
Yes.
Okay. Are you guys ready? Let's check it out. Okay, here is one super cool lesson 30, and let's go ahead, ooh, it's a terrible color. Let's go ahead and hop right into this. So, you all know, I'm just going to refresh your memory. You all know that we can rewrite any division expression as a fraction. You all know that this fabulous division symbol can be replaced with a fraction bar. Okay, it is paramount, meaning super important, that you recall this wonderful fact in today's lesson, lesson 30. So let's look at C, 3.5 divided by 0.5. Please recall that this amazing expression, 3.5 divided by 0.5, can also be rewritten as a fraction. Sweet. What we're doing in this lesson, friends, is shifting these decimals out of decimal world and into whole number world. Here's how we can do this. We're going to multiply 3.5 over 0.5 by some fancy version of 1. If I multiply 3.5 divided by 5/10, if I multiply it by 1, it's not going to change the value at all. But we're going to be kind of tricky, and we're going to multiply it by some fancy version of 1 so that these digits will shift out of decimal land. Here's how we're going to do that. I'm going to multiply 3.5 divided by 0.5 by 10 over 10. Here is why. This fun friend that is never leaving, that so many of you were refusing to use today. Let's look at this, 3.5. When we multiply 3.5 by 10, we are moving this way on the place value chart to the left because we're multiplying, which means 3 is going to hop 1 space to the left, and 5 is going to hop 1 space to the left. So 3.5, and this is not shocking news, 3.5 times 10 is 35. So 3.5 times 10, okay, is 35. I'm with you, Mrs. Calamaris. What about 0.5 times 10? Well, it's not going to take too much brain power to recall. 0.5, okay, 5/10 on the place value chart, multiplied by 10, hop over 1 place value to the left. When we multiply it by 10, 0.5 is going to hop over here. Oops, that's not 0.5. That's 5 ones. I hope that some of you were screaming on the inside when I said that. Let's try that again. 0.5, here we go, 0.5. When we multiply 0.5 by 10, it's going to hop over here 1 place value, and it is going to become 5. Hello, thank you. So 0.5 times 10 is 5 ones. Okay. So now we've multiplied 3.5 divided by 5 by 10 over 10, which you guys know is just code word for the whole number 1. Don't be afraid. Now we have 35 over 5. Simplify that, 35 over 5, by thinking about 35 divided by 5. What is 35 divided by 5? It's 7. My lucky number. Let's check out some more here. We are looking at D in the same section. I just had to get rid of all that amazing work. So we're looking at 3.5 divided by, this time, 5/100. The first one we were dividing by 5/10. So let's rewrite this division expression as a fraction because you all know that this division symbol can be replaced with a fraction bar. So 3.5 divided by 5/100 can also look like this. So what we need to do is multiply this by some fancy version of 1 you all know that we can rename whole number 1 in fraction form by just making sure that our denominator, this number, and our numerator, this number, are the same. So our goal is to shift these two numbers out of their decimal form and into their whole number form, because whole numbers, let's be honest, no offense against decimals, they're just a little bit easier to compute mentally. So we have 3.5 right now, and we have 0.05. I need to multiply them by the same number, because in order for it to be a fancy version of 1, the numerator and denominator have to be the same. So I'm going to multiply them. How can I shift? Oh, of course, I have a low battery. How can I shift? I see how I can shift 3.5 out of decimal form pretty easily. We just did that with the first problem. I can multiply 3.5 by 10 to shift it out of decimal form, but I need to make sure if I multiply 3.5 and 0.05 by 10, 0.05 is still going to be a decimal. So I have to grab my tablet. I have to figure out what can we multiply 0.05 by? What can we multiply 5/100ths by to shift it out of decimal world and into whole number world? Well, what I need to do is to get 5/100ths to hop over. Sorry, I just had to run it over to the counter. I need these digits to hop over 1, 2 place values to the left. So I know I can multiply them by something. I need to multiply them by something that has 1, 2 zeros in it. Sweet. Well, I know a number that has 2 zeros in it is 100. So let's do that. Let's multiply 3.5 divided by 0.05 by 100 over 100. Don't get scared. 100 over 100 is a fancy version of 1. And let's see if that solves our problem. The problem being, it's not really a problem, but these numbers are decimals and we want them to be whole numbers. So when I multiply 3.5 by 100, what's going to happen is... I'm going to kind of break the rules here. I'm just going to change my colors. I feel like you guys are comfortable. You all are comfortable enough as to what goes on here that I can pull this trickery on you. So 3 is going to hop over 1, 2 place values to the left because we're multiplying by 100 and 100 has 2 zeros. And then this 5 is going to hop over 1, 2 place values to the left as well. So you can see that 3.5, and please know that I trust that a lot of you are doing this in your head. I'm using the place value chart just to support that. 3.5 times 100 is 350. Cool. And then we're multiplying 5/100ths by 100, which means both of these digits are hopping over to the left 2 places because 100 has 2 zeros in it. 5 is going to hop 1, 2 to the left, and then 0 is going to hop 1, 2 to the left. And 5/100ths times 100 is 5. Cool. Our answer here is 350 over 5. Let's think about how we can go ahead and simplify this in a few different ways. We can use long division, 350 divided by 5, or we can use some algebra. We can think, 350 divided by 5 equals some number, which can also look like 5 times some number equals 350. Well, I know 5 times 7 is 35. So I need to bring a 0 to the party. So 5 times 7 is 35. 5 times 70 is 350. So our final answer for this fun problem is 70. Let's take a look at a couple more now and continue to hopefully feel the rhythm in this lesson. Here we're looking at 4.2 divided by 7/10. We can rewrite 4.2 divided by 7/10 as 4.2 over 7/10. We are going to shift these digits out of decimal form by multiplying them by some fancy version of 1. What can I multiply 4.2 and 7 by so that each of these digits will shift over to the left one place value? I need to multiply them by 10 because I need 4.2 to shift over to the left one place value, and I also need 7/10 to do that. So I'm going to multiply them by 10 over 10. When I multiply 4.2 by 10, we get 42. When I multiply 7/10 by 10, we get 7. And I'm just going to show you that very quickly in the place value chart. I really hope that you're just imagining this happen in the place value chart in your heart. So we have 4.2 times 10, when 4 is going to end up here, and then my 2 will end up here because both of these digits are shifting to the left. Booyah. And then when I multiply my 7/10 by 10, this 7 is hopping over one place value to the left. Booyah. Beautiful. 42 divided by 7, simplified. 42, which is just 42 divided by 7. Last time I checked, 42 divided by 7 is 6. Beautiful. Let's look at this one. I'll change colors. Bears colors. Here we're looking at 42 hundredths over 7 hundredths. So I need to multiply, in order to shift these digits out of decimal form, I need to multiply first of all, the numerator and the denominator have to be the same number, otherwise they would not be a fancy version of 1. So I need to get these digits shifted 2 places to the left. I need to get these digits shifted 2 places to the left. What do I have to multiply something by in order to shift them 2 places to the left? Well, I can multiply them by 100 and we'll be in good shape. That's 100 over 100, which again is a fancy version of 1. 0.42 times 100, just imagine these digits shifting. Just 2 place values to the left. 42 hundredths times 100 is 42. 7 hundredths times 100 is 7. Don't believe me? I will prove it using my best pal place value chart. I can make one anytime, anywhere, any place, out of any materials. So we have 42 hundredths times 100. Hop, hop 2 to the left. Hop, hop 2 to the left. 42, awesome. 7 hundredths times 100. We're going to hop, hop 2 to the left. And then the 7, hop, hop 2 to the left is 7. 42 divided by 7, still 6. Let's look at one word problem here, starring my friend and yours, our very own Miley. Miley is making bean bags. She has 6.4 pounds of beans. If she makes each bean bag 0.8 pounds, 8/10 of a pound, how many bean bags will she be able to make? So this is a word problem. We are going to read, we are going to draw, we are going to write. We read, now let's draw. Let's just draw. I'm just going to draw something that's meaningful to me. So this is all of Miley's beans, 6.4 pounds of beans. She is going to make these sweet little bean bags, and each of these bean bags requires 0.8 pounds of beans. 0.8. So what we need to figure out is if 6.4 is going to be divided evenly into groups of 0.8, 8/10, how many bean bags can she make? Sweet. Well, we've been working on this. So instead of doing long division with decimals, which can be pretty tricky, I'm just going to rewrite this expression, 6.4 divided by 8, as 6.4 over 8. I'm sorry, 8/10. Well, because we know all division expressions can be rewritten as a fraction. I'm noticing that we have numbers as decimals. I don't feel super comfortable with that. I want them to be whole numbers. I really like whole numbers. They're really easy to work with. So I'm going to multiply 6.4 divided by 8 by some power of 10 that has to be the same on the top and the bottom. I want these digits to shift to the left one place value. I know that I can do that by multiplying 6.4 by 10 because 10 has 1 0. So if I'm going to multiply 6.4 by 10, I have to multiply 0.8 by 10 because 10 over 10, as you all know, is a fancy version of 1. Not changing the value of this number, but we're just shifting it out of decimal form and into whole number form. So let's imagine what happens. 6.4 is on the place value chart, and you multiply it by 10. Each of these digits is just going to hop over one place value to the left. 6.4 becomes 64. And then 8 tenths, when it's on the place value chart, just to the right of the decimal. When we multiply it by 10, it's going to hop over one place value, and it's going to become 8 ones. Cool. 64 divided by 8, or 64 over 8, can go ahead and simplify to 8. So the answer to this fabulous problem is 8 pounds. Those are going to be sort of heavy bean bags. Have fun with that one, Miley.
Module for lesson 30, problems I and J, and what the heck? And we're going to be doing 3.6 divided by 3.6 divided by 1.2 and 3.6 divided by 1.2, 3.6 divided by, this is hard, divided by 1.2, Anyway, 3.6 divided by 1.2 is 3.6 over 1.2, and then you times it by 10 tenths because the 1.2 is in the tenths place, and that is 36 tenths because, well, it's 36 twelfths because 10 times, so if you were to do it on place value chart, it'd go to the left over 1, and then the 3 would be in the tenths place, and the 6 would be in the ones, so it would be, ones, and it'd be in 36 twelfths. So 36 twelfths is, so you gotta do 36 divided by 12 is 3, because 3 times 12 is 36. And that's, so our answer is 3. We're doing 0.36 divided by
0.1.
Yes, Muthu, my best friend here. Best friend. So kind of the same thing as last one. It's 0.36 over 0.12 divided by 100 100ths because the 0.12 is in the hundredths place, so that equals 0.36, right? Actually, no, it's not 0.36. It's just 30, which equals, I'm going to do it over here, 36 divided by 12 is 3, so our answer is 3, just like the other one. Yay, done.